Alright, so the next graph we're going to look at is an object falling down an incline, or sliding down an incline, if you will. What I have is I already have the data points up. I have one point here at 0. So the object starts at the top of the incline, right there, at rest. It's not moving. The word at rest meaning that it has 0 velocity. And after 1 second, it's traveled a total distance of 1 meter. So you're talking a really big track, actually. And then given more time, at another second, it's a total of 4 meters away. And then finally, at 3 seconds, it's a total of 9 meters away. So it's traveled quite a bit of distance. So basically, this is our situation. This is the data we collected. Now, if I want to interpret velocity, remember that velocity is nothing more than the change. Oh, right over here. The change, I'm going to write it over here. The change in position over the change in time. Okay? So, for the first second, my change in my position is a total of 1 meter. Okay? It travels that 1 meter in 1 second. So its velocity for the first second is 1 meter per second. Okay? Cool? Now, what about for the second second? Well, the change in my position, and I should do this, the change in my position for this is equal to 4 meters. Now, I could use this region in here, but I'm not going to do that. Instead, I'm going to go from here to here. It's 4 meters. It does it in 2 seconds. You can see how the math works out a little easier. So it travels a total distance of 4 meters in 2 seconds. That means that that's going to be 4 divided by 2. So we're looking at a velocity of 2 meters per second at 2 seconds. Excuse me. And then lastly, 9 in 3 seconds. Its total change in my position at this point is 9 meters, and it does it in 3 seconds. So 9 divided by 3 gives me 3. So right up here we're looking at 3 meters per second, some point right here. Now I should have used blue to represent my velocity like I did last time, but I left it over here. So what this graph is going to look like, it's going to start at 0, and then it's just kind of going to go like that. Okay? Cool? Now, I'm eyeballing my data points. This data point is considerably off. It should be something more like this. Okay, so there's my velocity graph. So once again, we remember that velocity is equal to the slope. Okay? So the velocity of my position graph, the slope of my position is velocity. And I'm using x as a shorthand notation for position. Okay? Now looking at my velocity graph, well, that's kind of interesting. Now, looking at these two graphs, I want to describe them real quick mathematically. This one, grab my red, is actually this equation. We'll say that y is equal to ax squared plus bx plus c. That represents that graph. Okay? This one's linear. We saw that in the last one. So that's going to be, excuse me, y equals mx plus b. Okay? Cool. Now, drawing my acceleration graph, my change in my position from 0 to 1 second, that is going to be a total of, change in my velocity is 1 meter per second per second. If I look at it all over again, I'm going to get the exact same number. Looking at it 2 seconds, 1 meter per second per second. Looking at 3, 1 meter per second per second. You can do it on your own. I mean, I showed you how to do it in the last video. You can do it on your own. What that looks like for the acceleration is, here's 0. The acceleration is a constant 1 meter. I mean, I didn't draw this very constant. 1 meter per second squared. Okay? So slope is acceleration okay. The area under this would have given me my displacement. Not really interested in doing that for you. You can do that. You can see that from 0 to 1, that's 1. It's a half. Okay. So the displacement here is representing 1 and 1 divided by 2. It's a half. So it's saying the displacement is about a half. It's not quite right, but that's okay. There's an approximation floating around there. But the area under that curve should be equal to my displacement. My acceleration, there's nothing that we can glean from this. The interesting thing is on that top equation, that y equals a squared plus b, or ax squared plus bx plus c. If x is time here, then this right here is 1/2 my acceleration. It's that kinematics equation. If x is time, then this is my initial velocity. And if x is time, this is my initial position. Okay? So in all honesty, this position graph up top is a representation. You have all the data you need by just creating that position graph and then fitting a line to it. Okay? So position, velocity, acceleration for an object falling down an incline. Okay? Thank you.